Hi, Mick McQuaid here to talk to you about NoSQL. So this is a follow-on of the previous discussion about a niche alternative to SQL. A much larger alternative, both in popularity and variety, is NoSQL. NoSQL typically requires programming expertise, which is not surprising because it began as a group of programmers rejecting SQL. They meant literally no SQL at first, no SQL exclamation mark, in fact, at first, but later softened their position to not only SQL because of market pressure, and most but not all NoSQL databases have some SQL capabilities. What are the properties of SQL? Properties of NoSQL. This should say properties of NoSQL. NoSQL databases have no schemas, and they require programming to enter and extract data. They're designed from scratch for what's called horizontal scaling. Horizontal scaling is the same as distributed databases, meaning that one database is spread across many machines. And they're optimized for specialized tasks, which allow high performance for those tasks, but make other general tasks difficult or impossible. And they're designed to allow data types to change over time, which is related to the lack of schemas. The kinds of NoSQL, according to Gemini, are document stores, key value stores, wide column stores, and graph databases. And I'm only really going to talk to you about two of these, document stores and graph databases. But I want you to be aware that there are many kinds. So document stores actually store data in documents, and they're commonly in JSON or BSON, which is binary JSON format, and the most popular by far is MongoDB. Then there are key value stores, which store data as collections of key value pairs, and Redis is the most popular of these by far. Then there are wide column stores, which store data in column families, which are optimized for massive data analysis. So Cassandra and HBase are examples of these. And finally, graph databases, which store complex relationships between data entities, and the most popular of these by far is Neo4j. So I'm going to talk to you a little bit about MongoDB and Neo4j. I'll talk about MongoDB in this video, and then in the next video I'll talk a little bit about Neo4j. So document stores. The most popular NoSQL database package is definitely MongoDB, which became extremely popular about 10 years ago. And its popularity has waned somewhat, but it's still in the top 5 at DB Engines. It's still being talked about a lot. And its basic unit is a document, which is a data structure composed of field value pairs. And it's not necessarily unique pairs, so it's not like key value pairs. And it looks like a JSON array, but it's more flexible than a JSON array. So here's an example of a MongoDB document. I think I got this from Wikipedia or someplace. Maybe I got it from the MongoDB website. But all of these fields are optional except _ID. This is required. Every MongoDB document has an _ID with an object ID, and obviously you don't type that in. That's automatically supplied by MongoDB. And then everything else is optional, and it can vary from one document to the next. So let's say, for example, we later get a phone number for Alice, so we can put phone number in here also, and that's fine, even if we don't have we have another document for Bob, and Bob's document doesn't have a phone number. The value in a field value pair can itself be a field value pair, so it's hierarchical or potentially hierarchical. And we can have repeating groups in it too, like this. So it contains a hierarchy, it contains a repeating group, and we can later add or subtract field value pairs except for _ID. Now, I'm going to skip key value stores and wide column stores and go right to a very different kind of database, the graph database, next. Thanks for watching this one, and graph databases will be our last one.